Good evening. Thank you for attending this talk. My name is Steven de Vries. I'm the CTO of Continuum Security. We're based in El Corazón del Somontano in Barbastro. So we're a Spanish company. My experience is, at the moment, I'm divided between doing programming, so I'm 70% spending my time doing development work, and 30% doing consultancy work and security testing of applications. Can I see a show of hands in the audience who identifies as a developer? Who is doing development work? A few, okay. And whose primary role is in security? Yeah? A few. Okay. So a lot of this talk is going to be the mix of these roles, how we integrate security into development and how we can speed up the processes of security to match the speed of development. So firstly, there's a huge gap in how we do security testing and how we do almost every other type of automated test in development. Developers have been doing automated tests for years. They've been writing unit tests, they're writing integration tests, functional tests, acceptance tests, and there's a wealth of experience there in how they've been able to write quick, fast tests and get quick results from these tests for their applications. Security, on the other hand, we've had a different approach to doing testing. We rely heavily on manual methods to do our testing. We primarily rely on penetration testing and ethical hacking as the one most important security testing activity in the development lifecycle. And the thing about security testing is we tend to export the expertise to an external group. Either this is an external company who comes in and does our testing for us, or it's a security team within our company who comes and does this. The point is that it's not owned by developers. Security testing is someone else's responsibility. And to understand how we got there, we have to look a bit back and see how we're developing software at the moment. So the start of the software revolution really happened with Agile, where developers and the business said, we can no longer follow this waterfall method of development. We can no longer spend 6 months doing design and then 6 months coding and then a year later figure out this is not the application we wanted. This is not a way to develop software. So we broke software down into smaller chunks. We started writing individual features. Each of these features has a component of design, coding, and testing built into it. And automated testing was a key part of doing Agile. You had to have an automated test to verify that the thing I wrote actually works properly. The advantage of an automated test is clear. It costs us nothing to run a test. That means if we have 1,000 tests, 500 tests, 10,000 tests, we can still run those tests very quickly and we can have a very good overview on whether the application we wrote works as expected or not. The interesting thing about tests is that if your tests are always passing, they are an accurate reflection of what your code is doing. So they can almost do double duty as documentation. That means you can, if you have detailed enough tests, you can use them as the technical documentation for your application. So all of these great benefits of Agile finish over here, at the end of the development environment. So developers are doing Agile. They do development within their development environment. At the end of Agile, they have a working product which they can then take and hand over to operations and say, well, now you deploy it into pre-production, now you do the additional testing and deploy it into production. So for security tests, this model works quite well, because we have a distinct phase here between pre-production and production, and we can do our security tests either in prod or we can do it in pre-production, because there's a distinct deploy phase, and that works fine to do our pen testing or ethical hacking. So the problem with Agile is we have this handover between the dev environment and the ops environment, or the pre-production environments. And we run into problems like this. Developers say, our application works. And the ops team says, well, actually, it doesn't work in the production environment. And the developers say, well, that's not our problem. It works in dev, and it may not work in operations. So the business said, well, if we can get fast feedback from our tests in development, can't we extend the process, the agile process, into pre-production so that we can have an automated process all the way from design to build to integration to acceptance tests, and we can have fast feedback from those tests all the way through this process and skip this distinct handover into pre-production. So this is continuous delivery, where we deliver into a pre-production environment in one automated continuous flow. And the next logical step is to say, well, if we can do that into pre-production, if we've got our automated acceptance tests that previously were manual tests, can't we extend those all the way into the production environment so that we have one continuous pipeline all the way from dev? We can make a change in dev, and we can see that change propagate all the way through our environments, running tests in different environments until it finally lands in production and we have our change in effect. And the famous examples of this are companies like Etsy, who the developers on their first day get to make a change in development and see that change working in production on that very same day. Because they have this automated pipeline, it costs them almost nothing to do a deploy into production. Some other examples, even relatively conservative organizations like gov.uk is following this process and doing more than 10 deploys a day into production. Amazon, 300 deploys across their entire application infrastructure per hour. So what does that mean for security tests? If we're relying on our ethical hacking and penetration testing here once a year, twice a year, and we're making 300 changes per hour, that means we're exposed to a huge amount of risk of all these changes that we're doing to the application that aren't undergoing any kind of security testing at all. And really, if we want to answer this question, we don't have to look very far, because developers have already solved this problem, and they've solved it for quality testing. In the same way we used to have a dedicated quality testing team that all they did was QA testing and nothing else, that has moved slightly so that we have a reduced quality testing team, and those types of tests are now automated and part of dev. Devs themselves are writing their integration tests and they're writing the acceptance tests before they arrive at any manual testing procedures. It means our tests are closer to the code. So that means when we can run the test quicker, and we can get feedback that something is failing much faster than relying on an external manual process. And I claim that we can do the same for security. We can take that same logical step to automate these types of tests, these security tests, and pull them into development. We may not be able to get 100% coverage, but we can at least get 80 or 90% coverage and do something to address the risk of so many rapid changes to our application without any kind of security testing. So the important question, if you like this idea of doing automated testing, the first question you need to answer is, who owns the tests? If we have a continuous pipeline from dev all the way into production, and we have these tests running all the time, what happens when a test fails? Who responds to that test failure? And does a test failure block my delivery process? So a lot of these need to be answered and are based on the fact of who owns those tests. Who responds to them? Who maintains them? Option A is that your security team owns those tests. So you haven't really integrated security into the development process. What you've done is you've automated a set of tests. They're still owned by the security team, which means the security team needs to respond when those tests fail. You won't have as much collaboration with the development team because they still have that same mindset. Security is not my responsibility. It's someone else's responsibility, and I can rely on them to go and find the security problems. So what that kind of model allows you to do is to go for a process like this. I call it semi-sec DevOps, right? So we can still have our regular delivery pipeline for our normal tests, our normal functional tests and acceptance tests, which are automated. But our security tests would have to run in parallel. It means they cannot block this process. Because if a security test fails, and only the security team can respond, then it takes far too long for them to go back to the developer and say, okay, we've got a security test failure, why did it fail, let's go and figure it out. It's far too long if you're doing 300 deploys an hour, this just cannot scale to meet that pace of development. Manual tests are still necessary. We can't completely eliminate the need for having an intelligent human actually doing clever testing against an application. However clever our automated tests can be, they're always going to be behind the intelligence of a human tester. So the way you could run manual tests is to run these on a periodic basis. You follow your regular penetration testing schedule, but ideally any test failures that come out of manual testing can get coded up into an automated security test. So you end up creating this bank of automated tests. Even if your pen testers find something interesting, great. Write that up as an automated test, put it in your bank, and you can now run those at almost zero cost at any time during your delivery process. So 6 months down the line, a developer changes something in the application, and the test that you wrote 6 months ago is now ready to catch any problems in that test. A second option is that you can have more integration and more collaboration between the developer and the DevOps team and the security team, in that the DevOps team own those tests. So they say, these are our tests. If a test fails, it's my responsibility to fix it. But I can use security as a backup solution. So I can go to my security team and say, well, this particular test, I don't know why it's failing. I don't know what the problem is, and I don't know what I'm trying to test with this test. So they can come back to the security team and use them like a backup process. And the final option is then to have one team, and this is the DevOps dream, to have a single integrated team where you have different team members. They might have different strengths and different weaknesses. You might have one person who is more security inclined than a different person, but they're all doing a bit of everything. So you spread the knowledge within the team, and you don't have a silo of us versus them. I think that's one of the things that the security industry is particularly guilty of, is that we like to think of security as something special. You know, we're the security guys, and we're the only ones who know how to fix these particular problems. We need to let go of that idea and say that we all want the same thing. We all want to build the secure applications, and if we can all move towards that goal, then so much the better. So with these last two types of models, if the ownership rests with developers, then we can start using integrated security tests that are part of our pipeline. And we can have blocking security tests. My security test fails, that means my deploy fails. And we're not going to deploy into production because we have a security failure. But importantly, you need to be able to respond to this fast enough to not delay the business and to not delay that process. So I've been talking very lightly about automated tests and so on, but let's get into a bit more detail about what exactly is an automated security test. So there are a few different types of tests. The first one is the fact that we've already got lots of automated security tools. We've got automated scanning tools, static scanners, we've got dynamic testing tools, dynamic scanners. And so these are already doing an automated job for us, but there's a difference between running a scan and running a test. And the primary difference is a test has only two outcomes. It passes or it fails. But if you run a scan against something, the outcome is a report with hundreds of findings. So what we need to be able to do is to transform that report into pass or fail. And we can do that by wrapping the tools with a test and using some logic within our test to transform that information into a simple pass or a fail. We then also have our known security requirements. So upfront, before we even start doing any development work, or even before we start deploying any applications or building any infrastructure, we know some of the security requirements that we want right at the start. We know which ports are meant to be open on that server. We know which SSL ciphers we want to support on the SSL server. So those are known things we can test for and put them into tests, and we can have a very clear pass or fail if they meet our requirements or not. These are one of the easiest ones to write tests for. And then at the application layer itself, we can then test for more functional type of aspects. And this is sort of a gray area between functional testing and between functional security testing. Things like, am I locked out of my account if I enter the wrong password 4 times? So that's a functional test, and it's also a security test. So we can test for those types of things as part of our security test suite as well. And the last one is probably a bit more complicated and requires the most work from us. And this is where we take a test that has been done manually, so something that the ethical hacking team has done, or the penetration testing team. They found some vulnerability, and we need to write a custom test that describes exactly what they found, so that we can have an automated version of that test. So to address all of those types of tests, we created the BDD security framework. And BDD is interested in supporting all 4, but out the box, we support the first 3 the best and the easiest. So BDD stands for behavior-driven development. You may have heard of TDD, test-driven development. So BDD takes this one step further and says, automated tests are great, they're wonderful, we like our automated tests. The problem with automated tests is that they're written in a programming language. That means only programmers are going to understand my test. And if we're looking at a cross-functional team like DevOps or DevSecOps, we have many non-programmers that are part of our team, and we want everybody to understand our requirements. So BDD was primarily invented for acceptance tests to allow business analysts to write a test, a functional test, and then the programmers can interpret that. And we've taken that and turned it into security testing, which was the focus of the BDD security framework. So under the covers, it's an open source framework, free to use. You can download it off GitHub. Underneath it uses JBehave as the BDD framework, so it's based on Java. We then also use Selenium WebDriver to drive a browser. We use OWASP-Zap, Nessus, some internal tools that we've written as well. And what we provide is a set of pre-written baseline security specifications. So if you wanted to write functional tests that work for Amazon and eBay and Citibank, you're going to have a tough time defining one set of tests that works for everybody because they are such different sites. But security doesn't have this problem because we have more or less the same type of requirements for most sites. So what we've gone for is a middle-of-the-road OWASP type of approach for testing, so we can write one set of baseline tests, and we can then very easily just change parameters within the tests to adapt to our own security requirements. So some examples. So this is the first very simple example. This is written in BDD security, and this is JBehave, what JBehave looks like. So there are a few things here which are part of the syntax of JBehave: the meta, the scenario, and the given, when, and then. And this is the format of our tests. So we're saying we have a scenario, which is a BDD lingo for a test. So every test maps to a scenario, and a group of tests is called a story. So I have one story here inside, one scenario inside my story. And you can see it's written in a natural language, which can be any language. It supports most of the international languages. We're doing a simple port scan here. So we're looking at the target host from a base URL, which we grab from a configuration file. We're then testing the TCP ports from 1 to 64535. We're scanning with so many threads and so many timeout. We're then grabbing all the open ports, and we only want port 80 and 443 to be open. And this is our test. This is executable. Every line here is backed by a bit of code. So you can execute this as an automated test. So in fact, we're actually looking at 3 things here, or 2 things. We're looking at, firstly, an executable test. So this is the same as a JUnit test or any type of unit test that we would run. We can run it. It costs us nothing to run this. It's very fast. At the same time, it's a specification. Because we can write this test before we start writing any code. And we can have this as documentation to give not to the penetration tester, but first to the person who's building the server for us, saying, this is what I want from my server. And the guy who's building the server can say, I know what you want from the server. I'll configure the firewall to meet this specification. So effectively, we've gotten rid of this documentation layer where we said, this is what we want, and this is how we're going to test for it. We've now got one version of the truth, which is this test. And it says, this is what I want, and I can run this thing itself to test whether I've reached this level of truth. A more complex example. So this is how we're using Nessus to do our testing of the infrastructure for us. This is an example of wrapping an existing tool in a test. So again, we're not doing any rocket science here. Nessus is doing all the hard work for us. It's actually doing the test for us. What we're doing is interpreting that into a yes, a pass, or a fail test result. So firstly, we talk to our Nessus server, we log in, and everything you see here that's in green is a parameter, which means that non-programmers can edit this plain text file and change the location of the Nessus servers, change the policy, add different hosts that they want scanned, or any other parameter within the test. So we have this kind of interaction between non-programmers who can now change features in the test for us. So the interesting part about this test is what we do at the end here, because we need to arrive at a pass or a fail from a Nessus scan report. So we follow the same process we would manually. We have a list of 1,000 vulnerabilities, and if you give this to a security analyst, he's going to say, well, now I need to figure out which of those is false positives. And the first time you run this test, you would have to add manually which of these findings are false positives, so that you have a bank of known false positives for this particular test run for this particular application. And the final step we do is then to decide how or when are we going to pass and when are we going to fail this test. So again, this depends on you and your level of appetite for risk. You may want to have this lower, you may want to have this higher. So those are both of those are touching on infrastructure. We did port scanning, we did a wrapper around Nessus. But how about testing the actual application layer? So if we manually test the application layer as penetration testers, we'd use a browser connected to something like OWASP Zap or Burp, and we'd use that to then test the server. What we're doing with BDD security is using Selenium to drive the browser, and we're using OWASP Zap API to talk to Zap, so that we can automate anything that you could have done as a manual tester, we can now automate using BDD security. So apart from all the logical tests, let's just look at the scanning part of using OWASP Zap to test the security of an application. So this follows the same formula as we did for Nessus. Firstly, we're going to navigate the application, and if you've used any of those proxies, you'll know that they're only going to scan traffic that they've seen. So if you're using Burp or Zap, you have to navigate the application first. You have to fill in forms, you have to submit data, and then tell Zap, go and scan this for me. Because if you don't do that, you're going to miss a lot of functionality within the application. So what we do is, we have a separate story which controls the navigation of the application. And here is our navigate app story. And it says we're going to start a new scanning. We're going to first navigate the application by calling this method. And what's behind this method is Selenium. I'll show you this in the demo. But we have a set of Selenium steps that describe how do we go and navigate this application. So how do I log in? How do I then submit a form or make a purchase or do something interesting in my application to then have that scanned by Zap? So we define that in Selenium. Once we have that, we can then define URLs to exclude. So we don't want the scanner to go hit the logout link, because then all our tests are invalid. So we can add other URLs there. And we can then use Zap's built-in spider to spider the rest of the application and find more content just in case there's more content there. Okay, so after we've done the Navigate app, we can then configure a scanning policy in ZAP. The way we've done it in BDD security is to separate each vulnerability branch. So we've got a separate test for cross-site scripting scanning, we've got a separate test for SQL injection, LDAP, and so on, so that you can be you can have more granularity in deciding which tests to fail or which tests to pass. And we do the same thing here with the false positives. We exclude known false positives from the tests, and then we have our passing or failing criteria. So the false positives here, we store them in a separate file. It's a plain text file, and we can add the URL, the parameter, and the CWE ID so that these don't count towards our test passing or failure. So the interesting thing about false positives, of course, from a process perspective, is somebody goes and adds a false positive that isn't a false positive, you've now got a problem because you've got a passing test which perhaps shouldn't pass because you've actually got a vulnerability there. The nice thing, though, is that it's all plain text, and the tests themselves are part of your code. So these tests, the whole BDD framework, is stored in source code repository along with all your other acceptance tests and along with the source code of your application itself, which means that you can track who made changes to what text file at what point. So there's traceability for all false positives, and for any change to anything within the application that might have an impact on security. So this is what the this is what the scanning scenario looks like. And when you run the test, it generates reports in JUnit format and also in HTML format. So we can see a nice HTML report which shows us where our test failures are. And this is what a test failure would like. We can say we've got more than medium risk vulnerabilities. In fact, we've got 2 medium risks. We've got an SQL injection over here and another one somewhere else. Okay, so we can get test failures and we can get information about what the test failures are immediately. Okay, so let's have a look at what this framework looks like. I don't think you can see much like that. Let's try our luck with 720. Yeah. Okay, so this is what the BDD security framework looks like. It's a simple Java project. It runs Ant, which means you can integrate it with almost anything. We've got our set of pre-written tests. So we've got a number of pre-written tests. For example, around authentication, we've got tests for that the password should be case sensitive, that the login form should be over an HTTPS connection, and so on and so on. We have data security tests to test the cache control headers we want set. We have tests around what headers we expect from our web application, XFrame options, and so on. We have our Nessus tests, password. We have session management tests, which tell us how we want the session to behave. When the user logs out, is he actually logged out? Can he go back and then re-access the session? So typical, the type of issues you'd find in the OWASP top 10 and the other OWASP standards, we try and include as much of those as possible within the baseline set of tests. We've also got tests around SSL, SSL, which are quite detailed. So we can, for example, have a specification that says exactly which SSL protocols must not be supported on the server and which should be supported. Which ciphers we want to see on that SSL server. Okay, so to be able to run these tests, you need to do some configuration with the BDD security framework to get started. Step 1 is to edit a configuration file. So we edit a config.xml, and we've got some general configuration items here, like which WebDriver instance to use. We currently support Firefox, Chrome, and HTML unit. So I've got Chrome configured here. We need to configure the base URL for our application. So I'm going to run some tests against this app. So this is a simple application, Bob password. It's vulnerable to a number of things, so we can see how it behaves. So the base secure URL is the SSL URL of that same app. At the moment we don't have one, so I'm using SSL Labs. We then need to define a class which contains the Selenium steps. So remember at the Zap scanning session we had a navigate method, so we need to define that navigate method in a class, and this class is also going to define some other methods that will allow us to do the functional authentication and session management tests for us. Okay, so we've got some other configuration options which are unnecessary. We need to tell the framework which users we have, and a few other configuration items. Right, so let's have a look at that class file which contains our Selenium steps. So this is what it looks like. This is a more elaborate class file which contains a lot of additional information that you don't necessarily need just to get started with the app. If you just wanted to do Zap scanning with a navigate method, all you needed is this navigate method here, which says open the login page, log in with one of the users in my config.xml file, verify that you see the welcome message, go and view someone's profile and search for the text test. That wasn't me. There we go. Okay, and just search for the word test. So we just want to generate some traffic for Zap, and then Zap can go and scan it for us. If we want to do some more elaborate testing, now we want to test authentication, we want to test session management, so we need to tell the framework how to log in and how to log out. And we do that by defining, well, firstly by implementing these two interfaces, I log in and I log out, and we need to tell it using Selenium how to log in to the application. So this is not all that complex, because you can use Selenium's own IDE to generate that information for us. We can record and play back that information. So if we wanted to do a login here, I'm going to open up Selenium IDE. This is what it looks like, and it's going to record all my steps in its own syntax. So I'm going to log in as Bob with password and click login. So just those actions, well, let's click one more. Let's click on view profile. Those actions have generated these Selenium steps, which have now been recorded by Selenium. And Selenium, we can also tell it what our format, our code format we want from that, and we can select Java JUnit. And if we copy that, Control-C, and go back to our code and paste Control-V, we have almost 100% valid code, which shows us how to do that login for us. So we just need to rearrange this to fit into what the framework wants. The framework wants an open login page method, which means that one goes over here, and the rest of them are already defined in this method here, which is just login and click the login button, basically. Okay. So we can now run these tests, and we can run them quite simply directly from the IDE. So we can run a story. So what I'm going to run is I'm going to run this authentication story. So as I said at the start, a story is like a test suite. A story contains a number of different scenarios. We've got this tagged as the authentication story. So we can run this as the authentication story, and we'll just run this story and not anything else. Run. The framework's going to fire up two browsers. Browser 1 doesn't use Zap, it does any tests that don't have to use Zap, and browser 2 does use Zap and does any tests where we actually have to use Zap to do those tests. And that's the authentication story done. So we've logged in, we've done a number of authentication tests, and we can view those results here. So we can go to view our HTML reports. We have an overview report saying we have 1 successful test, we have 4 failed, and 3 were excluded from this test run. We can view these results in HTML. So the first test was that passwords should be case sensitive. Turns out this application has passwords which are not case sensitive. So you can enter a password uppercase, password lowercase, they both succeed on the login form. Our login form itself is not presented over an HTTPS connection. We were expecting a URL that starts with HTTPS, but we actually got a URL which starts with HTTP, therefore test failure. And so on. So developers can see very easily using a browser what the test failures were within their application. Okay. So this was running the tests from the IDE. Typically, where you'd want these tests to be is on your integration server, so something like Jenkins. And since it's just based on Ant, it generates JUnit output format, which Jenkins can understand, and it generates HTML formats, which we can also publish in Jenkins. This actually works quite well, simply running within Jenkins. So that's an example test run of how it would run there. Oops. So this is our same vulnerable application, and this is demonstrating the complete workflow that the developer would see when they're running this tool. So they would go and make a code change to the web app itself. They're going to go and change something in the app, how they're doing queries, how they're getting the user information. They would push this up to the source code repository. Upload it. You would have your Whoa. There we go. So you would have your Jenkins configured to watch the source code repository. Whenever there's a new change, it would go and download the new web application and build it. So we have 2 jobs there. We have the regular build my web app job, and then we have a security testing job which runs after the application has been built and deployed. So firstly, Jenkins goes, downloads the normal web application, deploys it to the pre-production environments and runs any tests that are needed for the pre-production environment. Then automatically it will kick off the next job, which is the BDD security job. And this is BDD security running, doing its thing and running the browsers. So you'll see lots of clicking around and so on that's not needed for Jenkins. This all just happens automatically. Also, with this example, I'm using an actual browser, but you don't have to see this. You can run this in headless mode with XVFB on Linux, and you can still use Chrome, an actual Chrome instance. You just won't see the Chrome instance running. So there's no need to actually have a GUI running here. This is also heavily speeded up. It's not actually this fast, but that's entirely down to Zap. Running the functional tests, does the scanning for us. And we have test results. So we have new test results. We have 4 failures, and we can see 24 failures, and we can see what those tests failures are right over there. Apologies, this is not playing nicely. Hi. And if we've got our code repository integrated in Jenkins, then in fact we can go and see what the issue was. We can get our test failure message right within Jenkins. And we could even navigate to the code changes that caused this issue. So we can click on the commit where these failures occurred. and we can then see what has changed since these tests have failed. So what is the likely causes of my security failures? And we can get the HTML reports, which give us, it's a bit of a nicer interface than the JUnit test results, which are sometimes truncated. So if you want to find out exactly which URL and which parameter and so on, the HTML reports are, they give you a bit more detail about that rather than just the JUnit results. So we can also do some more interesting tests here, which are authorization tests. And we can actually test whether user A can see user B's details. But we need to do some upfront configuration to get that to work, primarily by extending that Java class. And we need to say, if I'm user Bob and I go and view my profile, I then see my secret data, which is Bob's email address. And the framework can then automatically go and test whether Alice or admin can access that same page, and do they then see Bob's data. So that's a feature provided by the framework, and is an additional test that we can run as part of the test series here. Oops, sorry. Right, so that was our framework, BDD Security. There are a number of other frameworks that have a similar approach, that they use BDDs, they use a natural language, and then they have underlying automated tests that are run as part of the framework. So the most famous one is Gauntlet, which is written in Ruby. Gauntlet is basically a wrapper around other tools, same way that BDD Security is. The primary difference between our framework and theirs is that they're focused more on infrastructure scanning. So they have like a wrapper around Nmap, so you can run Nmap and decide test failures based on Nmap output. What we were interested in doing is testing more at the app tier. So using Selenium, we can actually get inside the application. We can run tests within the functional areas of the application, rather than just looking at the infrastructure level. There's also Mitten, which is released by F-Secure, and they use Python and Burp. The nice thing about Mitten is they emphasize fuzzing. So they use Burp's fuzzer. You do need to have a commercial version of Burp Intruder, though, to use it. It's based in Python. And I think if you're doing low-level type of testing, if you're testing a protocol and you want to write tests for the protocol, then Mitten is a very good choice to use for that. We also have another project called Zap JUnit, which is the same type of concept as BDD, but throwing out the BDD thing and saying, let's do the same type of thing, but just using JUnit and just doing scanning and nothing else. So this is a nice way to get started. If you don't want to use the whole BDD layer, you can extend this project, also open source. And then there's also a OWASP Zap plugin for Jenkins, which will let you run Zap as part of Jenkins, but then you're 100% using Zap's functionality. So you would have to do the navigation of the application somewhere else. What the plugin can do is it can just do the scanning for you, but not necessarily the navigation. Right, I think we have some time for questions. Y se puede preguntar en castellano o en inglés. ¿Preguntas? Yes.
Hi. So thanks for the explanation. And my question is, I used to work in a company which is merged between financial and technological company, where we testers and developers had very different credentials, for example, or very different. Sorry. We used to have very different type of credential levels towards the applications. So only the security guys, for example, were able to deal with ports and make scans and so on. And so the question is whether you propose that it should be that the development team, the testing team, and the security guys would be merged all together in one team or in one even business unit, because many times they are completely separate from each other. So do you think that in the future companies should go to that strategy, merge all?
Well, I think the only answer I can give to that is it's going to depend on the company. And what the lessons learned from Amazon and from Etsy and from these companies is that if you do have a cross-functional team, then things happen faster and you can solve your problems faster. But if you have an organization that for security reasons or for compliance or policy reasons or whatever, you cannot have this team, then I think that the best you can do is at least have knowledge shared within the team, and even if they have to use different access levels to get access to the application, well, then they use different access levels. But I think the thing we can learn from DevOps is that at least if we can have a team that isn't reliant on one particular member who knows everything, and if that member isn't present or isn't available, then our entire process stops. Then we can have something that works. If we can diversify a bit in our skills, I think we're in a more resilient position to respond to change. Anybody else? No? Yes.
Estas herramientas funcionan principalmente ¿con qué lenguajes de programación? ¿Contra qué lenguajes de programación?
Pues todos funcionan, todas estas las herramientas de prueba funcionan contra una aplicación y da igual del lenguaje que está escrito la aplicación. Entonces, el BDD Security está basado en Java.
So DBB Security is based on Java, where we test a web application. So it doesn't matter what is behind the application, PHP, JavaScript, it doesn't matter. If you can see a page, we can test it. So regarding which tool to choose, it will depend on the team. If everyone knows about Python and no one knows Java, it will be more comfortable to choose a Python tool. Any more questions? No? Well, thank you very much, everyone, and have a good evening.